This is Chapter 12, Section 2. It's air, noise, and light pollution. So the objectives are going to be to describe 3 possible short-term effects and long-term effects of air pollution on human health, to explain what causes indoor air pollution and how it can be prevented, and then to describe 3 human health problems caused by noise pollution, and to describe solutions to energy waste caused by light pollution. Air pollution damages the lungs. That's kind of the big picture thing to take away from this. There's other little details here that I'll mention. So, air pollution adds to diseases like emphysema, heart disease, lung cancer. In other words, diseases that were already existing, air pollution will make those worse. It's kind of like if you had some sort of cut or rash. I guess a rash would be, like an ant bite. If that ant bite's there, but if you scratch it, it makes it worse. And that's kind of how you can think of air pollution. And, sometimes it causes certain diseases, but other times it kind of irritates those existing diseases. And this is a big thing to keep in mind, is that air pollution has actual economic costs. It costs up to tens of billions of dollars a year in health costs. And what I'm getting at is that we tend to think of, or some people tend to think of, environmental science, and it's kind of like those tree huggers over there, hugging their trees and whatever, meanwhile we're focused on the economy and money and stuff on the other end. But it's not always that simple. Where if you just ignore the environment and you're over here polluting the air, that does have economic costs, because we as humans, we have to pay for that. We have to pay for that in healthcare costs. We have to pay for that in loss of productivity because your workers can't breathe as well. So there, in other words, there's kind of a balance that you can find there, where there's actually a legitimate business interest in trying to have better air quality and better worker safety. So some short-term effects of air pollution on health. There's a lot of short-term effects on air pollution on health, like headache, nausea, irritation, coughing, bronchitis, pneumonia. And the good thing is that these short-term effects can be reversed if you can decrease the air pollution. So in other words, not everything that's coming from air pollution is this fatal, you've been exposed to air pollution, your life's over, man. You better just kind of give up. It's like some of these effects can be reversed, so long as it's not, continued for, the entire lifetime. But with that being said, there are long-term health effects of air pollution. Being exposed to air pollution at high levels increases your risk for emphysema, lung cancer, heart disease, and then it can worsen medical conditions, as I mentioned earlier. And I added this slide in here just to kind of give you a picture of what the upper respiratory tract looks like. So you got your throat, your trachea, and then your lungs right here. Where how the lungs are set up is that they have these little branches. So it's think of them as roads, maybe, where you got main road, and then it branches off, and you keep branching until you get to these little pockets called the alveoli. And what the alveoli do is they exchange the oxygen that you breathe in. So the oxygen that comes in gets exchanged with carbon dioxide. And if you remember from biology class, carbon dioxide is what is produced in cellular respiration. So whenever all the cells that make up your body are undergoing metabolism, a byproduct is carbon dioxide. Just like the burning of fuel in your car, a byproduct is carbon dioxide. A similar process where we breathe out that carbon dioxide. And so meaning these alveoli, you want to protect these little structures. They're kind of little sensitive guys, where if you're breathing in dust and junk like that, it's getting all the way down into these alveoli, and it kind of scratches them. You kind of create these little tiny scratches in them. And if just like if you've I know for me, I have a couple different scars that are on my knees from like falling and getting big cuts in my knee. Whenever you get cuts, you get scar tissue that forms, and that also applies to your lungs, where whenever you're breathing in all this air pollution, over time you get these little tiny cuts that occur in the alveoli, and those cuts heal with scar tissue, and that scar tissue doesn't allow the exchange of these gases here to occur as efficiently, as well. Another thing that can happen, and this is getting into like asthma and bronchitis, is air pollution can cause these airways to close up. So maybe if you get exposed to air pollution and you have asthma, your bronchioles will start looking like this. They'll start, this wall will kind of close in so that you don't get as much air that comes through here. All right, indoor air pollution. I guess ironically, depending on how you look at it, or interestingly, indoor air pollution can actually be worse than outdoor air pollution. And that's because a lot of really anything that's in our house, nowadays, carpets, furniture, building materials, your paints, they all have chemicals in them, chemicals that those volatile organic compounds that we talked about earlier, those VOCs. I'll write it again, the VOCs. These things are in our furnitures and stuff, and so whenever they, because they're volatile, whenever they go from their little liquid state to gas state, that forms air pollution inside a building, and it happens. It becomes a big problem in buildings that are tightly sealed, so like kind of airtight buildings. And this happens especially either down south, in Texas where I'm from, or up in the north, where in Texas you want to keep the air conditioning in, and up north you want to keep the heat in, keep the cold out and the heat out in Texas. But because you tightly seal the building, you're also keeping inside the building all of those air pollutants that are coming from the furnitures. All those different, the furniture, the building materials, paint, all that stuff that we have inside the home. And so that can lead to what's called sick building syndrome, where it's essentially, workers or anybody living in those buildings can get headache, fatigue, eye irritation, dizziness. And it's especially a problem in hot places where you just don't tend to get as much ventilation of air. And so the solution to the sick building syndrome is going to be finding and removing some of those sources of the indoor air pollution. Would be the kind of the obvious options. Like if you have some furniture that's releasing a lot of these chemicals, you remove it. The other is to have good ventilation, so making sure you're getting a good flow of old air and new air, so that the air is not just staying in one place. And then especially whenever you're doing any sort of renovation, you want to make sure you have good ventilation going on. Radon gas. This is another kind of indoor air pollution and it's an example of a naturally occurring air pollution, where radon is it's an element that occurs naturally in the earth, but it's produced by the radioactive decay of uranium. So uranium will decay and it'll produce radon, this radioactive element that will form radon gas, which is this colorless, tasteless, odorless, and radioactive gas. And colorless, tasteless, odorless, why those are important to make note of is because it's hard to detect radon gas, because you can't see it, you can't taste it, you can't smell it, but it's there. It's there, so it's kind of hard to detect. And because it's a gas, it can seep through all the cracks and holes that are in the foundations of homes and offices and schools, and it can then adhere to the dust particles that are in the home. So that's another thing to think about whenever you have your cleaning lady or you clean the house, is a benefit of removing dust particles is to prevent things like radon or those chemicals, those VOCs that are coming from your furniture, to prevent those from clinging onto the dust particles that are all around your house. So anyways, what happens with the radon gas is whenever people inhale that dust, that radon's going to enter their lungs, and that radon is going to go all the way to the cellular level, to the cells that line the air passage, those bronchioles that I showed you earlier, and it's gonna harm that genetic material, and it can create enough mutations in the DNA where you can have cancer develop. So radon is the second leading cause of lung cancer in the United States, right behind smoking. And radon can kind of, so if you're someone who smokes and you're exposed to radon, that you kind of get a double whammy. You get hit 2 different times with your risk for cancer. I skipped over this, and I wanted to come back to it, but this is a beautiful summary slide of this entire section, and it's it's kind of one of those pictures where if you don't have the proper context, it's going to make you freak out about everything in your home. So not every home has these issues that are pointed out here, but any one home could have one or multiple of them. So I'll kind of start from the top left, where you have your household cleaners, where these cleaners have those VOCs. That can release a bunch of chemicals. You have nitrogen oxides that can come from an unvented gas stove, fungi and bacteria from dirty heating and air conditioning ducts, carbon monoxide that comes from either a car left running or a furnace that is just old and isn't undergoing the reactions efficiently enough, so it's producing a lot of carbon monoxide. You got methylene chloride that comes from paint strippers and thinners, the radon gas that I just mentioned, formaldehyde. So formaldehyde is one of the bigger ones. That's those chemicals that are coming from your furniture, carpeting, particle board, foam insulation. That is one of those indoor air pollutants. If you smoke in your home, tobacco smoke, and then para-dichlorobenzene is what something that comes from mothballs, and then some of your air fresheners. So it, if you're constantly having an air freshener in your home, yeah, it makes things smell good, but technically this, it's really not that healthy for you because you're getting exposed to this compound here. And truthfully, I don't know that we really know all that much about how much of this para-dichlorobenzene that you can be exposed to and not really worry about it. Then you have tetrachloroethylene that comes from your dry cleaning fluid. So whenever you take your suit or something to get dry cleaned, even whenever you bring it home, that suit's still going to be releasing some of that tetrachloroethylene. Asbestos. So asbestos are these silicate fibers, these minerals that we can use to form these really tiny fibers, and they're really very useful things because they're heat resistant, they're flexible, and they're durable. But what makes them really useful for building materials is also why they're so toxic to human health. So because they're really durable and flexible and heat resistant, and they're small, they form minute or small fibers, they can get all the way down into the lungs, even all the way down to the alveoli, that very ending point of the lungs where you exchange the gases, and they just, because they're durable, they just accumulate in there, and they just kind of wreak havoc on your lungs. And asbestos is used as an insulator, as a fire retardant, and because it's so toxic to the worker, especially the workers who are working with it, and homes of people who are living in it, the government ended up banning it in the early 1970s. And so kind of a big, a legitimate business for people is if you're a certified asbestos worker who can go around to schools or home and start removing some of that asbestos that's still left over in some of the older buildings. And this is just mentioning what I already said. Next thing is noise pollution. So noise pollution, really a lot of this stuff is kind of a little bit of a duh, like, oh, noise pollution, it can make you go deaf if it's too loud, or it can stress you out or give you high blood pressure, which is all true, but something also to think about with noise pollution is how it can affect whales and dolphins. So whales and dolphins and some other aquatic organisms will use like echolocation, so they really rely on those sound waves in order to help them navigate throughout the water. Meaning, if you have noise pollution, if you have a lot of extra noise that isn't normal to nature, that can affect how these whales and dolphins navigate, and so they can end up getting stranded on beaches. Some terminology with noise pollution is the idea of a decibel, and it's just a unit it's the most common unit that's going to be used to measure that loudness. Where 0 decibel is going to be the faintest amount that the average human ear can hear, and then each time you go, each increase in decibel is going to be a 10 times higher level than the previous one. And a sound of 120 decibels is that threshold of pain. So right at 100, as soon as you get above 120 decibels, for most normal people, that's going to be painful to them. And once you get above 120 decibels, that's where you can start getting permanent deafness that starts occurring if you have continuous exposure to that. So really a kind of a handy chart, and something I would really encourage you to take a little bit of time to think about is, especially when you think to that 120, that threshold of pain, which is a rock concert. So if someone who goes to a lot of rock concerts, that's why kind of people go to a lot of rock concerts or rockers. They tend to be hard of hearing because they're kind of slowly killing their hearing. Jet engine, rocket engine is way above the threshold of pain. A car horn, chainsaw, portable CD player. And notice this 120 there. So some of your CD players, just because it can go louder on the CD player doesn't mean you should do it, because depending on the song or what kind of player you have, you can get all the way up to that threshold of pain level. The final pollution is going to be light pollution. So light pollution not only is just kind of, it blocks out the stars, it does have more than just an aesthetic, type of harm. It can cause like legitimate health effects like headaches, fatigue, stress, anxiety when you're exposed to too much light. And then specifically when we're talking about light pollution as it's related to energy use, if you have inefficient lighting, that can diminish your view of the sky, and inefficient lighting is just everywhere, where it's one of the biggest waste of energy that we have. Like, think of all those, all the lighting that goes on the billboards. I don't know. It's not too hard to go around a city and see inefficient use of lighting. So a solution to inefficient lighting can be trying to shield some of the light so that's going downward, rather than just having a light that's just shining, wasting a bunch of light energy by going upwards where we don't need the light. Trying to direct it downward, using time controls so that it only goes on when it's needed, and then using more efficient light sources like a low pressure sodium source is going to be the most efficient sources of light. Alright, that's going to do it for this section.